Welcome back, everyone. Thank you for joining me once again. My name is Robin Clark, and this is Chapter 2 of the Quick Start Guide series for ExtendSim. This guide has been broken down into 5 chapters. This video is on Chapter 2. We will learn the basics of how to run a model, and we will discuss the components of a model. As seen here, when ExtendSim launches, it opens an application window with the following items: a model on the left, library windows for each library that opened on the right, and tool menus on the top and side. By default, the model that opens will be the Getting Started model. If that option has been removed, a new blank model will be opened instead. Now let's open the model for step 1. First, select the File menu and then select Open. The Open Worksheet window will appear. We want to navigate to the Discrete Event folder. In this folder, you will find the Step 1 DE tutorial model. Select the model. This opens the model window as shown here. This example model uses 6 blocks to simulate a simple system where cars enter into a line and go through a car wash system. Notice the tabs at the top of the model window? What you see here is the model worksheet. The worksheet is where the model resides. These windows are notebook windows. A notebook window provides a central place for storing inputs and outputs. Let's run the model and see the results. I want to show you 3 methods for running the model. I will then let you pick your favorite. We could click on the Run Simulation button on the model toolbar. We could select the Run and Run Simulation on the menu. Or we could use Ctrl-R on the keyboard if you like keyboard shortcuts. As the simulation runs, progress information will be displayed in the status bar at the bottom left of the primary window. With a small model like this, however, and the animation turned off, the messages may go by too quickly to be read. ExtendSim provides built-in and customizable 2D animation on the block icons and on the worksheet. I want to show you 2 methods for toggling the 2D animation on and off, and then I'll let you pick your favorite. You may select the Show 2D Animation on the toolbar. Or you may select Show 2D Animation in the Run menu. Let's run the model again. With the animation on, the queue and activity blocks, which are labeled Entry Line and Wash Bay, show the buildup of cars waiting to be washed and the status of the wash bay. There are many ways to see information during and at the end of the simulation run. For this model, information is reported on graphs and data tables, in a notebook, in block dialogues, and through the animation. ExtendSim comes with a number of flexible charts to use in models. This model uses a line chart block. The line chart block in this model has information entering into 2 of its input connectors, so the graph displays 2 lines. Double-click on the line chart block. In this case, the blue line shows the cars washed and the green line shows the cars waiting. The Line Charts Data tab shows the data points that produce the line. The Line Charts Dialog tab has options for when to show the graph, when to auto-scale, and so forth. Let's go back to the model itself. Earlier, we talked about the model worksheet and its notebooks. Notebooks are customizable tear-off windows that can be used as a dashboard for the model to control the model parameters, report simulation results, and to document the model. The important parameters and tables from the dialogues of blocks in the model have been cloned to the notebook. In the simplest terms, ExtendSim models are composed of blocks and connections. As the model run, information goes into a block, is processed and/or modified, and is then sent to the next block, usually by a connection. Blocks are stored in repositories called libraries, as shown here. Each block in ExtendSim represents a portion of the process or system that is being modeled. Blocks have names that signify the function they perform. The Q block, for example, will have the same functional behavior in every model you build. You can also add a label to a block to indicate what it represents in your specific model. The label can be set from the block's dialog and can be seen from underneath the block. A block's icon is usually a pictorial representation of its function. For instance, in this model, the block labeled entry line is a Q. Its icon symbolizes a holding tank. Most blocks have dialogues associated with them. To access a block's dialog, double-click on its icon. Dialogs are used to enter values and settings before running the simulation. Some dialogs calculate and display results that are generated as the model runs. At the top is the block's global object ID, its name, the name of the library it resides in, and its label. Take note that the global object ID is a unique number in the model and will often be used in error messages. Most dialogs have tabs across the top like this for entering input values and setting, getting results, controlling animation, and so forth. If you leave a dialog open during the simulation, it will slow the run, but you can watch the impact on different variables. This interactive simulation capability means you can even change some of the settings in a block's dialog during the simulation run. At the bottom of the dialog is a help button. It provides information about the block. This might include the purpose and use, the connector usage, the descriptions of each dialog item, and so on. To the right of the Help button is a text block where you can enter the block's label. The View pop-up is for changing the icon's orientation or appearance. Now let's take a closer look at connectors. Most blocks in ExtendSim have input and output connectors. Connectors are used to get data into and out of a block. The behavior of most connectors is predefined for each specific block. For example, if you want to change the delay time of the activity block during the simulation run, then you could connect other blocks to the D connector of the activity, and the activity knows what to do with the values that are input into that connector. For the activity and all other blocks, you can get information about a connector's function by clicking the Help button in the bottom left-hand corner of the block's dialog, or you can see the user's reference. Connection lines are the mechanism used to transfer data and information between blocks. Let's look at the connectors more closely. The blocks in the item library have primary connectors for passing items as well as secondary connections for getting and passing values. The item connectors are the square green connectors on the left and right of a queue. The green border connector on the left is for items going into the block. The green filled-in connector on the right is for items exiting the block. The value connectors are represented by gray squares and are used for getting and reporting values. The input value connectors are usually on the left and are light gray in color. They are used to control specific block behavior. The output value connectors are usually on the right and are solid gray in color. They are used for providing specific results. Both the value in and value out connectors highlighted here are variable value connectors. The item in connector is also a variable connector. Variable connectors are usually designated by a dark arrow. Let's look at how we can expand and contract the connector array. Hover your mouse over the dark gray arrow. Not the input connector, just the gray arrow. If you are in the correct spot, the cursor will turn into a double-headed up-down arrow indicating that the array of connectors can be resized. Once the cursor turns into the double-headed arrow, click and drag down on the arrow until the desired number of connections are exposed. Watch how to expand and contract the connector array. Now that we understand connectors better, let's look at making connections between blocks. There are 3 ways to make connections between blocks. First, we can use a line connection. This joins the output of one block to the input of another using a connection line. ExtendSim uses the point and click method to physically draw connection lines. Simply point to the first connector, click, and then point to the next connector and click. Let's see this in action. Next, when an ExtendSim blocks connector is right-clicked, a special smart block technique can be used to add blocks to the model and, at the same time, automatically connect it to the original block with a connection line. Let's watch this in action. Next, to use the bump connect feature, click on the block and then bump its inflow connector to the outflow connector of a block already on the model worksheet. Let's see this in action. Next, named connections use text labels as outputs and inputs, causing the data to jump from the output to the input without using additional connection lines. The throw and catch feature allows for remote connections. This is discussed in the user's reference. Let's discuss libraries for just a moment. Libraries are repositories for the blocks used to build the model. When you open up an existing model, ExtendSim automatically opens the libraries that contain the blocks used in the model. Libraries can also be manually opened, closed, and created in the library menu. By default, when you open ExtendSim, a library window for each open library opens and docks to the right side of the primary window. To change that, see the Edit, Options, and Libraries tab. The libraries listed in this list will be automatically opened when ExtendSim opens. The libraries with checkboxes selected will be displayed to the right of the dockable window when ExtendSim opens. To create discrete event models, you will primarily use blocks from the item library. However, it is common to also use blocks from other libraries that ship with ExtendSim, especially the value and the chart libraries. Let's look at what they are typically used for. Blocks in the item library are optimized for modeling services, manufacturing, material handling, and other discrete event systems. These blocks have been specifically designed to meet most discrete event modeling needs, allowing you to quickly and easily perform complex modeling tasks. The value library blocks are useful for data management and model-specific tasks. For example, the equation block is for creating compiled equations from a simple operation to a full programming environment. The blocks in the chart library are useful for any type of model. The most commonly used block is a line chart, which traces a history of values over time during the simulation. This concludes the video for Chapter 2. In the next video, we will go through a tutorial to build a simple model.